A little bit different schedule today due to some planning time in the afternoon for teachers. So here's your schedule. Hopefully your fifth hour teacher let you know this as well. But yesterday, I should say, we have class till 9:35. At 9:40, your fourth hour class will start and go to 10:45. Sixth hour will go from 10:50 to 11:55. And then fifth hour will meet after that. So it's a little bit different in the fact that you're going to go 2, 4, 6, 5 instead of 2, 4, 5, 6. And that's because of lunch for those who are here. If you have questions, let me know. I can answer them to the best of my knowledge anyway. We may not have time today to do our breakout room meetings. It will just depend upon how long the lesson takes. So, it's not a long lesson, which is nice. So we should have time. But if not, we will not have time. Yeah, so sixth hour today is going to be before fifth hour. Again, just so they could get all 4 classes meeting time and be out by 1:20. It just worked out best that way. So kind of crazy, but that's the way it worked. And your parents, I hope, got an email with that schedule earlier this week, or maybe even at the end of last week. All right. So, just real quick, today we're going to cover 8.5. On Wednesday, we covered 8.4. So, to keep you on track or on schedule, you should have 8.4 note check and homework already completed. And then the 8.5, which we'll cover today, make sure that's completed by the end of so if you missed anything from before break, everything that was due before break, with the exception of the quiz from 8.1 to 8.3, has been marked as missing. So if you had something that wasn't completed, it is now marked as missing. And obviously that affected your grade because it makes it a 0. If you get that stuff turned in, it will grade, and I will update your grade when it's turned in. I believe 4-week progress reports are due next week, which means that'll be like the cutoff for work from the first quarter of the first third of the trimester. So just be aware of that. That day is coming. Like I said, we may not have much work time today or time for those weekly check-ins, unfortunately, because of that adjusted schedule. All right, question, any other questions? A couple came up in the chat. I think I answered them. One thing that might be helpful today is a graphing calculator. Again, if you have the Chromebook that has the app for the graphing calculator on it, Otherwise, there are apps for your phone, and I believe I have those um, in the uh, Schoology folder. If not, I will put them, I'll make sure to put them there. I thought I had them in there, but that might have been last trimester. So we're going to look at applications of quadratic functions today. So ways that you can apply quadratic functions and answer questions with them. And again, if you're planning, next week we will cover 8.6, and then the end of next week we will have a review and a quiz on 8.4, 8.5, and 8.6. So all sorts of good things coming up. So again, if you have work that's missing, get that done so that you're not falling further behind as we finish up chapter 8. And then we get to chapter 9, which is all sorts of fun. I mean, I know the rest of this is fun, but chapter 9 is all sorts of fun. So, all right, here we go. So, a company offers a rectangular pool size with dimensions as shown. Each pool includes a deck around it. So what we're going to do is write a function to model the area of the pool and the deck. So I know in the packet it didn't copy real well because the brown and the black were pretty close. But as you can see, I hope we're calling this part X and this part 2X. And then this little square is 4 feet. And so all of the corners are 4 feet by 4 feet. So that deck around it is 4 feet wide, and then the lengths are different. So we're going to write a function. So I'm going to write it as f of x. And, you know, it's a rectangular pool. So how do I find the area of a rectangle? You could, oh, there we go. There's a chat. The chat's a buzzing now. All right. Yeah, excellent. So a couple different ways that you can find the area of a rectangle. Some people call it base times height. Others might say length times width. They mean the same thing. So if I look at this part as my length, I'm going to write an expression for that length. And one of the reasons I filled in the 4s like that is I think it's easy to see. I take 4 plus 2x plus another 4. So my length is 2x plus 8. And I should maybe have darken that part in or show, oh, I guess I did on the top. And then the width would be 4 plus x plus 4. So x plus 8. And that expression, and we can certainly leave it in intercept mode, although later on we're going to find out that multiplying it out and getting it in standard form is actually going to be a little bit more helpful. But there's our expression in intercept form. So then we're asked, what does the x represent? So the x is this part right here. And I would say the x represents the width of the pool. And the pool only, not anything to do with the deck around the pool. F of x, I'm going to move my f of x a little bit. And what does f of x represent? F of x, the function that we wrote, represents the area of you can see right up here of we could find it if Mr. Gingrich's computer was there. We go of the pool and the deck. All right. So here's a question that we're going to have to answer. Carolina wants a 15-foot wide pool with a deck. So the pool is going to be 15 feet wide. The deck is not included in that 15. So just to be clear on that. How many square feet will she need to have available in her yard? So we're going to take 15, plug it in for x in our function. One way to write that, we're going to find f of 15, which means we're going to take 2 times 15 plus 8 and multiply that by 15 plus 8. Two times 15, pretty sure that's 30, plus 8 is 38. Okay, order of operations, I do what's in the parentheses first, and in the parentheses, I have to do the multiplication before I do the addition. My other set of parentheses just has addition, so I take 15 plus 8. So 38 times 23 if we multiply that out. So here's where using your calculator might be helpful. Oops. Let's see. So if I use my calculator, 38 times 23. And we get 874 square feet. And actually, maybe more important than the number of square feet, she would have to have 38 feet for the length and 23 feet available for the width. But it just asked for the number of square feet available. All right, questions? Important that we label that correctly. All right, here's one for you to try. Use a quadratic function to model the area of the rectangle below. Then evaluate the function with x equals 8. So I'll give you a few minutes to go ahead and give that one a try. And then we'll take a look at some answers when the timer goes off. If you have questions, don't be afraid to go to the chat and let me know, and I will answer them as you're working. All right, so let's take a look real quick. Now our area is going to be length times width. So there's a function to model that area. If we evaluate that for x equals 8, this first set of parentheses, 3 times 8 is 24, minus 9 is 15. 8 plus 2 is 10. So pretty, I like multiplying by 10 or multiples of 10. It makes it a little bit easier. So we get 150. We don't have any units here, so I would just say square units, just so that it has a label. All right, so that's one example of how we can use quadratic functions to model situations in real life. Another one is something called vertical motion. So this is motion straight up and down. So there's an equation for vertical motion, negative 16 t squared plus v sub 0 times t plus h sub 0. And this is vertical motion on Earth. And the reason I want to be specific about that, that negative 16 is the effect of gravity on things that are on Earth. So if we were not on Earth, that negative 16 would be a different value. You'll see that later. In this case, the h of t just represents the vertical height, the height above ground at any time t. V sub 0 is the initial velocity. So it's the velocity we start with. Generally, things that have vertical motion start with a pretty, their velocity is the largest as it starts, because then gravity starts to affect it. H sub 0, that's the initial height. So I know one of the questions we had in the past was someone threw a ball to their dog. And so, we said that, I think we looked at it on a graph, and the y-intercept was the height that they threw the ball from, where they released the ball. And in this situation, time, t, is measured in seconds. So this is all measuring in seconds. So, and height is measured in feet. So that's important to know. Different measurements would have, so if we were measuring in meters, we wouldn't have that 16 and a half, or we wouldn't have 16.5. We would have a different value there. Boy, I said it wrong again. Let me try this one more time. We would not have the negative 16 in front of the t squared if we were measuring in like meters. It would be a different value. All right. So generally, a vertical motion problem will be looking for one of two things: either maximum or minimum height, or the time it takes to reach the maximum or minimum height. The good thing is we know how to find both. The maximum or minimum height is the y value of the vertex. So if we can find the vertex, we can find the maximum height or the minimum height um, of a uh, vertical motion problem. Normally, we're going to look for maximum height because for it to be a minimum height, it would have to like go down and then go back up, and that's not going to happen very often. To find the time it took for the maximum or minimum height, we find the x coordinate or the x value of the vertex. And we can actually be very specific about that. In this case, the time is going to be our value b, the opposite of b, which is the opposite of our initial velocity, divided by 2 times a, and a, as long as we're talking about on Earth, is going to be negative 16. So some pretty specific values that we can plug in there. Excuse me. All right, finding then these things in practice. At a swim meet, James dives from a diving board that is 40 feet high. Her position above the water is represented by the equation h of t is equal to negative 16t squared plus 24t plus 40, where t represents time in seconds and h represents height in feet. Sketch a picture of the event. So she's diving off of a diving board. So there's my diving board, there's the pool below, and there's Jane. Let me try that again. There's Jane diving off the diving board, and she's going to go up off the board and come down into the pool. One thing that might be good to know, she starts at 40 feet high. And so we're going to find two things here. How long will it take Jane to reach the maximum height? And what is the maximum height? The nice thing is the way that they're asked, because it's easy to find how long it takes first. Then we need that value to plug in to find the maximum height. So how long it takes is the initial velocity, the opposite of the initial velocity, divided by 2 times the value for a. If you use a calculator to find this, you need to be very careful. Either multiply the 2 times negative 16 first, or you need to use parentheses. So I'll show you what happens if you don't do this the right way. So we have negative 24 divided by negative 32. So if you do it correctly, 0.75 or 3/4 of a second. If you just put it in the way that I originally wrote it, negative 24 divided by 2 times negative 16. Yeah, it didn't take 192 seconds for Jane to get to her maximum height. And the reason we get the wrong answer here, order of operations says we work multiplication and division from left to right. So it does actually negative 24 divided by 2 first, takes that answer and multiplies by negative 16. If we want the multiplication in the denominator done first, we would need parentheses. And then we get back to our correct answer of 0.75 seconds. And you could write it as a fraction or as a decimal. Then we're going to plug that in and find the greatest height. So her height at 0.75. And I will show you again one way you can do that with the calculator rather than typing this all in this way. 24 times 0.75, and our initial height was 40. So one of the things that I like about the calculator, it remembers the last answer that you used. So it's going to remember that 0.75. So I can do negative 16 times, if I go second and the negative symbol, that answer in this case is the 0.75. It's the last thing the calculator did. And I want that squared. Plus 24 times, again, that last answer, plus 40. Again, you could type in the 0.75 and square it, and 24 times 0.75. That works as well. Nothing wrong with that. This is just another way to do it. And so we get 49 as our maximum height, or our height at 0.75 seconds. So 49 feet is our maximum height. All right, so as I said, when we're on Earth, that number in front of the t squared is negative 16. If we were on the moon, astronauts working on a space station on the moon toss a ball in the air. The height of the ball is represented by the equation f of t equals negative 2.7 t squared plus 13.5 t plus 14. Excuse me, where t represents the time in seconds since the ball was thrown, and f of t represents the height of the ball in feet. Sketch a picture. Oop, sorry, I moved a little too fast. I appreciate you letting me know. There is the end of that problem. Yep, don't be afraid if I'm going too fast. If you missed something, didn't get something copied down, you know, holler at me, either unmute and holler at me, or send me a chat, and I'm happy to go back. And then just let me know when you're ready to go. All right. So now I'm going to draw my astronaut. And he's like 14 feet off the surface of the moon, or the ball is when it's released anyway. And he throws a ball. I don't like that. There we go. That's better. I don't know. All right, and the ball's going to go up, and the ball's going to come down. and eventually land back on the moon, we hope. Again, we're gonna try to find how long it takes the ball to reach the maximum height. And then question C, we're not gonna find when does the ball hit the ground. That's gonna be something for chapter 9. We're gonna find the maximum height instead. So we have our equation for height. To find the time it takes to reach the maximum height, we take the opposite of B. Divided by 2 times A. And again, we can calculate that either by hand or using a calculator. And it takes 2.5 seconds for that ball to reach its maximum height. What is the maximum height? Well, we're going to take our function, plug in 2.5. So negative 2.7 times 2.5 squared plus 13.5 times 2.5 plus 14. Again, I'll show you that trick with the calculator. Negative 2.7 times the last answer squared plus 13.5 times the last answer plus 14. $30.875. All right. Leave that up for a second, give you a chance to write it down. So one for you to try on your own. You're trying to dunk a basketball and you figure you need to jump 2.5 feet in the air in order to dunk the ball. The height your feet are above the ground is given by the function h of t is equal to negative 16t squared plus 12t. And if you want, you could add in there plus 0, because before you jump, your feet are on the ground, you're 0 feet above it. Find what your maximum height is, what the maximum height of your feet is above the ground. And then based on the information in the problem, would you be able to dunk? So again, I'm going to give you just a few minutes. And then we will come back together and talk about answers. So this problem just asks to find the maximum height. But in order to find the maximum height, we do need to find the time it takes to get to the maximum height. So I'm going to start by finding t, which is the opposite of my initial velocity, 12, divided by 2 times a. So 0.375 seconds to get to my maximum height. To find my height, I take 0.375 and plug it in. To find out how high my feet get off the floor. So -16 times, so if you didn't use the last answer option, that would look like this. And I jumped 2.25 feet. I typed it in and then I said it would look like this, but you couldn't see it. That's what it would look like without the last answer function. Sorry about that. So are we able to dunk? Unfortunately, we need to jump 2.5 feet. We only jumped 2.25 feet. No, we can't dunk. We are 0.25 feet short of dunking. All right. So I did double check. Homework is posted and ready to go. I am, as I said, our time is pretty short here. I am just going to allow you to go ahead and work on any of your work. And your next class will start in about 23